Machine learning is a subset of artificial intelligence (AI) that focuses on the development of algorithms and models that enable computer systems to learn and make predictions or decisions without explicit programming. Instead of being explicitly programmed for specific tasks, machine learning algorithms learn from data and experience to improve their performance over time. At its core, machine learning involves the use of statistical techniques and mathematical models to identify patterns and extract meaningful insights from data. The learning process typically involves three main components. 1. Training data. Machine learning algorithms require a large amount of training data to learn from. This data is used to teach the algorithm about the relationships, patterns, and features present in the problem domain. The quality and relevance of the training data play a crucial role in the effectiveness of the learning process. 2. Algorithms and models. Machine learning algorithms come in various forms, including supervised learning, unsupervised learning, semi supervised learning, and reinforcement learning. Each algorithm type is designed to solve specific types of problems. During the training phase, the algorithm adjusts its internal parameters based on the input data to build a model that captures the underlying patterns and relationships. 3. Prediction and generalization. Once the model is trained, it can be used to make predictions or decisions on new, unseen data. The trained model is capable of generalizing from the training data to make accurate predictions on similar but previously unseen examples. The performance of a machine learning model is evaluated based on its ability to generalize well to new data. Machine learning has found applications in various fields, including computer vision, natural language processing, speech recognition, recommendation systems, fraud detection, medical diagnosis, and autonomous vehicles, among others. Some popular machine learning algorithms include linear regression, decision trees, support vector machines, neural networks, and deep learning models. It's important to note that machine learning is a rapidly evolving field, and researchers and practitioners continue to develop new algorithms, techniques, and approaches to improve the performance, scalability, and interpretability of machine learning.